Hello and welcome to day 13 of Python Challenge. And today we're going to talk about web services. So without further ado, let's get started. So we have a lot of different systems uh, in the internet, and we have to have a standard in order for those different systems to talk to each other. We have primary two formats that we are using right now. First is XML, and the second one is JSON. So again, here we have like a presentation of different systems. For example, we have a PHP, Python, Java, and JavaScript systems. These systems needs to talk to each other, and we have to come up with the protocol that these systems, uh, all of these systems can understand and can interpret them in order to transfer data on the internet. So the first one is gonna be the first standard is gonna be XML. In this example, we are moving from moving data from a Python system to a Java system. Uh, as you will see later, square bracket is being used for to identify the XML data. And what we have to do, we have to serialize and deserialize it. So serialization means basically that we break up the data in a small chunk so it will be easy to be transported over the internet. And the deserialization is basically the reverse of that action, which is the assembly of those small pieces and uh, making the whole file that we are trying to transfer. So this was XML, and the next one is JSON. So if you notice here, the the main difference, one of the main difference is that here we are using uh, curly bracket. So in XML we were using square bracket, in JSON we're using curly bracket, and the same concept of the serialization and deserialization applies here as well. So let's talk more about XML. So XML stands for Extendable Markup Language, and the primary purpose of it is to help information systems share structured data. And XML was a simplified subset of Standard Generalized Markup Language, or SGML, and it's easy to read for human, so it's relatively human legible, as it says here. So about the XML basics, we have start tag, which here is identified by green. Basically, any tag uh, starting with a square bracket can be a start tag. The end tag is identical to the start tag. It just have a forward slash at the beginning of the tag after the square bracket. Then we have the text content, which is identified here by white. So in this case, we have the name, chalk, and the phone number, which is the content of this name tag and the phone tag. And we have attributes. Attributes are presented here by orange. In this case, we have an self-closing tag, which is email, with attribute hide, which is yes. So this email address here is being hidden in real world because it has this hide attribute. And the final one is self-closing tag, which is basically one tag, doesn't have a end tag, but at the end of the tag we have a forward slash, so it identifies that the tag ends at the same line or within the same square bracket. It doesn't need the second end square bracket tag. So for XML, uh, we basically are not concerned about white spaces. So in this case, you see that we have two identical XML files. One is indented a bit, and that's only for more readability function. Is nothing to do with the uh, functionality of the XML. So these two files are identical, and the white space uh, basically does not matter in XML. The only the only time when the uh, white space matters is basically this. For example, in the phone number, you see between the digits there are space, and this is how this number will be presented. So if we don't want to have this space on the presentation of this phone number, we can just modify and delete these spaces. But that's that's the only place that the um, white space matters, and the content of the data itself. But the presentation of the data, the placement of these tags, uh, does not need to be spaced out or indented or going to the next line, basically. Okay, so we talked a little about the terminology. Here we have more uh, information. So we have tags, which is indicate the beginning and the ending of the elements. We have attributes, which are keywords or value pairs on the opening tag of XML. We talked about serialization and deserialization, which is basically convert data in one program into common format that can be stored and or transmitted between systems in a programming language independent manner. Uh, Basically, yeah, that's the terminology of XML. So there are different representation of XML, and another one is uh, XML as a tree. So here we have uh, our root tree, which is our uh, first tag, which is A. Then we have two child uh, branches, if you will. The first one is B, which uh, has the text or element of X. So B would lead to X. And under C, we have two other branches, which are D and E. D has the context of Y, and E has the context of Z. So this is how we can present XML as a tree. So in this example, we talked about the representation of the XML text and attribute. So it's pretty similar to the first one that we talked about. Here we just have an attribute of W, which has the value of 5. So we can just put it under the, because it's after the B, we can just put it after the under the B, and it's going to be 5. And the other one, the text node of it would be X. So the attribute is going to be 5. The text node is going to be X. And we have XML as a path. So the way that this works is basically um, we have the same tree structure that we discussed. And in this case, we can say that, okay, for example, A will lead to B and B would lead to X. So we have A, B, X. So if we follow this path, A, B, we would end up getting to X. The other path is going to be A, C, D. So A, C, D would lead to Y. So that's why we have Y here. And the last one is going to be ACE, which is going to be this direction, which would lead to a letter Z. So this is another representation of the XML document. So now we're going to talk about XML schema. So schema is a description of the legal format of XML document. So it's basically like a contract that each system has to comply with. So in order to have a valid XML document, we should compare that XML with this XML schema to make sure that uh, the schema should validate uh, the document, and that's the way to make sure that XML is complying with the schema that we have, so um, everybody can agree on a same standard. So that's why we have schema. So in a nutshell, we have our XML document, we have our XML schema, which is like a contract. We have another entity which is called XML validator, and in this case, the validator check the XML document with the XML schema, and it gives a thumbs up in this case that okay, the XML document that we have is following this schema and it's good to go. So an example would be here. So we have a tag of person with the last name, age, and date of birth. So that's our document. The XML schema is, so it's each tag starts with XS column. Basically, that identifies that we are dealing with a schema. And so here we have the complex type name person. So this is going to be our author tag, which is person. And then we have a sequence, which means that we have a couple of other branches coming up this root tree that we have. So we have the last name, which the type of it is going to be string. We have age, which is going to be integer, and we have date born, which is going to be date. So these are the information that we have. We have the last name, age, and date of birth, which complies with the schema contract that we have here. So there are many different schema languages that we have. We have what's called document type definition, or DTD. We have a standard generalized markup language, or SGML. But what is mainly used and kind of prevailed right now is XML schema from W3C or XSD. So the XSD is a standard of World Wide Web Consortium, or W3C. It's often called W3C schema, and is is another way of calling it is called XSD, and because the file names, of course, and the name of the file name ends with .xsd. So another structure example that we have for the SXD here. So we have our element, which is identified by orange. So here we have, for example, last name, age, date of birth, and this is the identical structure that we discussed in a couple of previous slides. We have sequence here. Sequence means that okay, we're gonna have a couple of different elements. It's just not gonna be one. And we have a complex type. So complex type is a tag which, in this case, uh, have different elements. It doesn't have only one element. It has several different elements, and that's why it's called a complex type. So the XSD can impose some constraints. So for example, here we have our complex time person, and in the sequence we have uh, the element name, and which is going to be a string, and we have something which is called min occur. So we should have at least one first name. So that's one of the constraints that we have here. And the maximum, the max occur is also one. So we cannot have more than one name here. Um, so this is the first name. I'm sorry, the full name, which is going to be Tav Refsnes, and again, it has to be one, and it should not exceed one. So min occur one, max occur one also. The other one that we have is the other element that we have is child name, which is going to be the same as full name, which is string. The min occur is 0, the max occur is 10. So here it means that okay, we can have up to 10 child uh, mentioned under the full name that we have. So in this case we have 4. We could go up to 10. So in this case also the schema is validated, and this file is good. So we're gonna talk about XSD, sorry, data types. So uh, the first one, for example, the element name is customer type is going to be string, which means that okay, any text is gonna cover, string is gonna cover pretty much every text. We're gonna have a start, which the type of it is date, so this is gonna show us a date. We're gonna have a start date with the format of, with the type of date time, so this is gonna show us the date and time. And the time here is UTC/GMT or Z, which is a Zulu time. So that's how the time is being saved in Python. And also, I'm sorry, on the XML. Also, we have to notice that the date format is year, month, and day. Then we have another element which is called price with the type decimal, so we can have decimal point in this case. And we have another element which is called Vix, and the type of it is integer. So that's different type of XSD data type that we have. Again, so talking about the ISO 8601, which is a date time format. Um, the format of the date is going to be year, month, day. Uh, time of the day is going to be like this. And the time zone is typically UTC slash GMT rather than local time that wherever we are located. So this is another schema. Here we can see that, okay, we are looking for an address, and we're gonna have basically recipient. It's gonna be a name. It's gonna be the house, street, town. Uh, it's gonna have at least okay, it can have the name of the country. It can be zero also, it can be nothing. It has to have the postal code and the name of the country. And the name of the country here is predetermined as FRDEES, UK, and US. So that's how the uh, actual file, the actual XML file looks like, and this is how the XML validator, uh, I'm sorry, the schema of XML looks like. So again, in this case, the XML uh, matches the schema. So here we have another schema. Uh, in this case is a shipping slash ordering scenario. So we have the ship order. We're gonna have the name of the person who ordered it, and we're gonna have the destination. On the destination, we're gonna have the name, address, city, country, and the name of the and I'm sorry, we're gonna have another complex type here, which is gonna be the name, uh, which is gonna be the title, note, quantity, and price of the shipment that we have. Okay, so um, we can use a library in Python which is called uh, element3. So element3 can parse different XML documents, so it makes it easy for us. In this case, for example, we have a XML tag with person. So the name is Chuck, the phone number is this as an integer. I'm sorry, is international. I think that's INTL means. And the email attribute height is gonna be assigned as yes. So what we can do, we can import this library. So element3, and we have a shortcut here which means that as et. So basically every time when we use et, it's kind of like Python knows that it's we are referring to the element3 library. So in this case, we're gonna put the data that we have, which is this XML. We're gonna call this library upon it, and it will put the data which is inside this XML in a variable called tree. Now, what we can do is we can print, we can say that, okay, the name is, find the name in that text file that you created after you put it in the tree. And we can also get the attribute of the email, which in this case is yes. So the output of this is going to be name equal Chuck and attr column yes, which is the attribute of the email which we collected here. So another example, in this case we have pretty much the same. We have two users, so with the ID 1 named Chuck and the ID 9 named Brent. We're gonna get this as a input to our element3 function, and we put the content of it in the stuff. So we have lst, which is it's gonna find all of the users. So we have a tag called users with s, and we have another tag, we have two tags with the user. So this is gonna find all of those users, and this is gonna print the count of users. In this case it's gonna be 2 because we have two sub branches, if you will. And basically what we can do here is for all of the items in the list, which is 2, we're gonna have printing the name, ID, and the attribute of the XML users that we have here. So that's what we do here with this part of the code. So now we're going to talk about JavaScript object notation, or JSON. So JSON was discovered by Douglas Crockford, and it's not a new language. It has been used before, but Mr. Crockford has documented it and put it on the json.org website. So again, JavaScript object notation, or JSON. So a little bit of humor that JavaScript is lots of information, but we have another book which is called JavaScript, the Good Parts, and you can see that how much difference is between these two. So this is probably what we need to know JSON / Python here. So again, JSON is not a standard. It's not an IEEE or IETF standard. It's some, you can find documentation on json.org, but this is not a IEEE or IETF standard. So in this case, we this part of the program, we're just importing JSON, and what we have here is if you remember, we have square bracket, curly bracket here. So curly bracket represents JSON, and also in this case we have name, which is Chuck, phone, which is a nested dictionary in the data dictionary basically, and the type is going to be international, and the number is going to be this. And we have another um, kind of sub-dictionary, which is email, and the height is equal to yes, which is active. So here what we can do by importing JSON, we can put this data to it and it will load it to info. So when we print info slash name, we're going to get chalk as a name, and when we go to the email, it's going to get us the attribute of hide, which in this case is yes. So hide is going to be column, um, I'm sorry, hide is going to be yes in this case. So another example, we have in this case we have a list, which this list comprise of two dictionary. So here we have the ID is equal 1, the ID is equal 9, X is 2, X is 7 here, name chalk, name chalk. So these are two dictionary which are, each of them are, I mean both of them are in this list which is called input. So we're gonna load that using the JSON library, and that whatever comes out is gonna go to the info. We're gonna print the length of the info, which is the length of uh, the length of the list. So here we have this square bracket which identifies the list, which has two members. These two members each are a dictionary. So the length of this is going to be 2, and we're going to have for the length of the info, we're going to print the name, ID, and attribute of the member of this list, which are a dictionary. So now we're going to talk about the service-oriented approach. Basically, what we have is, for example, a hotel reservation system. So the hotel reservation system doesn't have all the information about the booking, the flights, or hotel, or car rental, but it can talk to all of those websites that can do those reservations for us. So what is happening is basically that hotel reservation or flight reservation system is talking to different services. To do that, it needs to talk to each service API, or which is called uh, application programming interface. So again, that flight reservation website or hotel reservation website talks to different other websites through their API, so it can retrieve and sort the information that we need based on criteria that we need. So it goes to those other websites, query those websites through the API, and bring us the information that we need. So again, the idea is that we have usually what happens is that, okay, we have one system. That system started doing a lot of things for us, so we split that system to do two different things. So each part is going to be specialized in doing one specific task. And because we have a lot of these systems, this system needs to talk. They need to communicate to each other, and the way for them to communicate is through the APIs, or application programming interface. So let's talk a little bit more about the web services. So we talked about the API. The API is basically it provides the functionality. Um, I'm sorry, the software that provides the functionality described by an API is said to be an implementation of the API. An API is typically defined in terms of programming language used to build an application. So again, the API is basically is an abstract in that it specify an interface and control the behavior object specified in that interface. So basically, it's a gateway for us to talk and communicate to other systems on the web. So there are different type of APIs. For example, Google has this geocoding API. So Google knows a lot about the location. So we can use this API with the permission of Google, of course, and we can query that to get some information. And an example would be here. So, for example, we're going to send this request. So this request is going to be getting information about this person, Ann Arbor. In this case, plus is um, a space, and percentage to C plus is a comma. So Ann Arbor, Ann Arbor, comma, MI. So we're gonna send this information to Google API, and Google is gonna get this back to us. So what we have here uh, is basically a location. We have address component, we have the short name, and we have formatted address. So this is what we get from Google after sending this request via the this web address. So now we can use a Python library to parse that information that we saw in the previous slide. So in order to do that, we're going to import these libraries, and we're going to import JSON, and we're going to define our service URL as this. So this part is basically identical in every single um, API request that we set for the geolocation to Google. So what we're gonna do, we're gonna receive, we're gonna ask for a location, we're gonna take it, and we're gonna parse through that address. So this is gonna add those address in the format that is needed for Google to get us that information. So we're gonna create that portion of the address, and we're gonna concatenate that with the service URL that we have here. So the result of this would be this basically. So this portion is identical, and this portion from address to here was created by this library here. So we added to that service URL, and we put the result in the variable called URL. So we're gonna print retrieving URL, which means that okay, we're gonna so first we enter the location, which is Ann Arbor in Michigan, and we say that okay, we are gonna retrieve that information, retrieve this URL, and basically we're gonna say that okay, um, decode and read this URL, and we're gonna URL request open. I'm sorry. So we're gonna the URL open is gonna send that URL to Google, and whatever comes back, which is in this format, is gonna be read and decoded, and we're gonna say that okay, the length of it is this much, and these are the characters of it. So in this case, we have 1669 characters, so we retrieved this many characters. This is a try and accept portion in case that the JSON load doesn't doesn't bring out anything, in case that data that we get for the JSON.load is nothing, is not valid. And if the status is not okay, we will print that okay, failure to retrieve. If everything is okay, we're gonna print the longitude and latitude of the JSON file that we received, and we're gonna print it. In this case, the latitude and longitude are this, and we're gonna print the name again, and we will be ready for entering the next location, which is going to be another loop of this code here. Okay, now we're going to talk about the API security and rate limiting. Basically what we talk is that those APIs are expensive because there are information that not everybody need, or not everybody can have access. So some of those informations are free, some of them are paid, we have to purchase it, and some of them are rate limited. Basically, we cannot exceed a certain amount of API requests per day or per certain period of time. And some of them, they have an API key which we need to authenticate ourselves to those services. So in this case, this information, I don't know if it exists still is the same, but in this case, the geocoding API for Google was rate limited to 2,500 requests per day, and the Google Map API for business was limited to 100,000 requests per day. So we're going to talk about the authentication and authorization. Basically, again, every API, for example, in this case, Twitter needs to be basically Twitter found that people make more money from the Twitter API than Twitter makes from its API. So they want to monetize it, of course. They don't want everybody to use it. So that's why they come up with this rate limiting and authorization process. So in this case, we're gonna this is another code that what it does is we basically it asking for a Twitter account, and what it does is goes and collect that information about that. I'm sorry, it will collect the the Twitter account for us, and in this case is gonna bring some information about the owner of that account for us. So in this case, for all of the users that we mentioned or the screen names, it's gonna print those names, and it's gonna print the status and the first 50 character of the text that is identified with the status of that user. So that's what's gonna happen. So in this case, we have Dr. Chuck as the name of the account. It will goes and it find the friends um, portion of the Dr. Chuck Twitter page. So in this case, we have uh, 14 of them, and what it does is just takes the status, put the first 50 character and some information about what time those status was created, where is the location, what's the screen name of the person who is a friend of Dr. Chalk, and the account name and the screen name basically. So this will be done for people who are friends with this Twitter account basically. So now we're going to talk more about the authentication. We have in order to talk to this authentication of the API, we need to have a consumer key, we need to have a consumer secret, we need to have a token key, and we needed to have a token secret, and we have to have all of these four in order to talk to an API. The standard that they are using, most of the APIs are called OAuth, which is, as discussed, this requires all of these customer key, consumer secret, token key, and token secret to be provided for the API in order for us to be able to use those information. So here another portion is basically we are importing the URL lib, we are importing the OAuth, and we are importing the hidden libraries. We will put the OAuth and the secret, and what it does, this piece of code will go and retrieve the OAuth information for a specified API that we need to have access to. So in summary, we talked about the service-oriented architecture. We talked about that, okay, we have these different systems, that each system does a certain piece of the job. This system needs to talk to each other, so that's why we need to have the API. And we also talked about the XML and JSON as a serialization and deserialization format and the standards that are being used in the World Wide Web right now. We have to give acknowledgement to Mr. Charles Reverence for creating these slides, and I hope this has been informative for you, and thank you for listening.